Our discussion this evening is on valency and valence electrons. Please, before you watch this video, if you don't know about shell electronic configuration, I advise you go back to our previous video that talked about electronic configuration, because that will help you understand what we are going to do now. Valency and valence electrons. We want to know what they are and the relationship between them. Valence electrons are simply the number of electrons in the outermost shell of an atom. The number of electrons in the outermost shell of an atom. This is oxygen atom. It has two shells, and the outermost shell is this. How many electrons is found in the outermost shell of oxygen? Oxygen has 8 electrons in total. The first shell, K shell, takes 2, while the remaining one goes to L shell, which is the second shell. So the configuration is 2, 6. The outermost shell has 6 electrons. Therefore, the valence electrons of oxygen is 6. Then this is sodium atom. Sodium has 11 electrons. The first shell takes 2 normally. The second shell takes 8 normally. Remaining 1. So the 1 electron moves to the third shell. So we have 2, 8, 1. The valence electron of sodium is 1 because it has 1 electron at the outermost shell. This is also applicable to argon. This is argon. Argon has 18 electrons. The first shell takes 2, second shell takes 8, making it 10, remaining 8. The other 8 electrons move to the next shell. So we have 2, 8, 8. At the outermost shell of argon, we have 8 electrons. Therefore, the valence electron of argon is 8. Okay? Good. Then, we want to talk about valency now. Before that, we want to refresh our memory in what we discussed in shell electronic configuration. The Bohr and the Bury scheme, the rule guiding electronic configuration. The first and third rule is what we are interested in here. The first rule is the 2n square rule, which says that K shell, which is the first shell, takes maximum of 2 electrons, while L shell, the second shell, takes maximum of 8 electrons. M shell takes maximum of 18, and so on. Rule 3 says that if the maximum number of electrons that can be accommodated in the outermost shell is 8. Okay, I will explain that later. Let's use potassium as an example. This is potassium atom, and potassium has 19 electrons. Let's look at the arrangement. Someone will say, okay, since potassium has 19 electrons, the K shell takes 2, the second shell takes 8, making it 10. So we have 9 left. Okay, now the third shell takes 9 because the third shell can take maximum of 18 electrons. M shell can take maximum of 18 electrons. But this is not right, because if you say 2, 8, 9, you have broken the third rule. The third rule says that as long as that M shell is the outermost shell, the maximum number of electrons that will be left there is 8. So since we have 9 left, and this is the outermost shell, we cannot put all the 9 electrons here. We can only put the 8 electrons and shift the remaining one to the next shell. That is why this is wrong. So the potassium atom has this configuration: 2, 8, 8, 1. 2, 8, 8, 1. This is also what happens in calcium atom. Calcium has 20 electrons. So you can say because it has 20 electrons, you say, okay, the configuration is 2, 8, 10. Because this last shell is M shell, I can take up to 18. No. Because when you do that, you have broken the third rule. Therefore, the configuration of calcium is 2, 8, 8, 2. The remaining 2 is shifted to the next shell. Okay? Alright. Then, coming to valency proper. When an atom has 8 electrons in its outermost shell, that atom is said to have octet structure or octet configuration. This kind of configuration is stable. For instance, this is argon. Argon has 2, 8, 8. In the outermost shell, it has 8 electrons, so it has octet structure, and this structure is a stable structure. Then, when K shell is the only shell, sorry, this is a mistake. When K shell is the only shell an atom has, and that shell has 2 electrons, it is said to have duplex structure, and this structure is also stable. So helium atom has 2 electrons, so it has only one shell. The only shell it has, both in and out, is only one shell, is this shell. So the only shell it has is the K shell, and this K shell contains 2 electrons, so it's complete. Because normally K shell can take maximum of 8, maximum of 2 electrons, sorry. Therefore, helium has duplex structure, and duplex structure is a stable structure. Do you understand? Okay. What is valency, and how can valency be determined using all these I've been talking about? Valency is the combining power of an element. The combining power, that is the ability an element has to enter into combination. Okay? So what does this mean? This simply means the number of electrons an atom of an element needs to gain or to lose in order to attain the stable duplex or octet structure. You know that because they want to be stable, they seek to be stable by trying to gain or lose electrons. That is why you see atoms of elements enter into combination. For instance, this is oxygen atom, and the configuration is 2,6 because it has 8 electrons in total. So the K shell takes 2, the next shell takes 6. If you look at this, it has 6 in the outermost shell. So valence electron is 6. But what is now the valency? The valency is the number of electrons it needs to gain or lose in order to be stable, in order to attain octet structure. So look at this. We have 6 electrons here. This oxygen may decide to lose the whole 6 electrons and only have one shell. And this one shell will have duplex structure, which is stable, right? Because it's K shell. Or it can choose to gain only 2 electrons. And once it gains 2 electrons, it will have 8 at the outermost shell. Therefore, it will gain stable octet structure, which is the plan. Okay, now to gain 2 electrons and to lose 6 electrons, which one is easier? You find out that it is easier to gain only 2 electrons than to lose a whole 6 electrons. Therefore, oxygen normally loses 2 electrons whenever it enters into combination. Oxygen normally gains 2 electrons whenever it's entering into combination. Therefore, the valency of oxygen is 2. The valence electron is 6. The valency is 2. This is calcium atom. It has 20 electrons. And this is the configuration, 2, 8, 8, 2. It has 2 at the outermost shell. So the valence electron is 2. Then what is the valency? It has 2 electrons here. So calcium can say, okay, let me lose 2 electrons so that I will have 2, 8, 8. If it loses these 2 electrons, it has 2, 8, 8, which is stable octet structure. Or it will now choose to gain 6 electrons and add to these 2 to become still octet structure, right? Then to lose 2 electrons and to gain 6 electrons, which one is easier? You see, to lose 2 electrons would be easier than to gain 6 electrons. Therefore, calcium normally loses 2 electrons whenever it's entering into combination. Therefore, the valency of calcium is 2. Then coming to argon. Argon has 18 18 electrons. So 288 is the configuration. And the outermost shell is 8. So valence electron is 8. If you look at this, the outermost shell has 8 electrons. If you look at this, you find out it doesn't need to gain any electron and it doesn't need to lose any electron because already it has octet structure. Therefore, the combining power or the valency is 0 because it doesn't need to gain, it doesn't need to lose. This is helium atom. It has only one shell, which is K shell, and it has 2 electrons. Remember, K shell, once K shell has 2 electrons, it is completely filled. And since it is filled, it has duplex structure, And duplex structure is also a stable structure. Therefore, helium is stable already. The electronic configuration is 2. The number of electrons at the outermost shell, which is valence electron, is 2. And valency is 0 because it doesn't need to gain any one because it's stable. It is stable duplex structure. Okay? Therefore, if you look at this, you will know that there is a little difference between valency and valence electron. Valence electron simply means the number of electrons at the outermost shell. While valency is the number of electrons an atom needs to gain or lose in order to gain stable duplet or octet structure. So we use valence electron to find valency. Are you getting me? We use valence electron to find valency. Sometimes the valence electron may be equal to the valency, but that doesn't mean they mean the same thing. For instance, in oxygen, the valence electron is 6 and the valency is 2. In calcium, the valence electron is 2 and the valency is 2. You just need to know the difference. Valence electron is the number of electrons at the outermost shell, while valency is the number of electrons it needs to gain or lose in order to attain stable configuration. With this information, I believe you can solve this study questions. Using electronic configuration, determine the valency and valence electrons of the following elements: hydrogen, lithium, carbon, nitrogen, and chlorine. I want you to do the same thing I did here. Draw their structures, tell me the configuration, and the valence electron and the valency. Okay? If you have any question, you ask me. Thank you for listening.